Hey guys, and welcome to this 1.26 math video. So if you don't do 6th grade math, once again, I do not suggest you watch this video. So let's get started. Today we're still going to be handling with Unit 1, which is numerical expressions and factors. And we will be doing 1.2, which is powers and exponents. So let's get started. First, the first example I'm going to show you is write each product as a power. So we have 4 times 4 times 4 times 4 times 4. Now first you're like, hey Rishi, you're drawing little dots, not multiplication signs. Well, in algebra, a multiplication sign equals a dot. And I bet you're like, why? Well, because when you get into higher level algebra, you're going to start using the term x. So let's say that you wanted to do x times y. X times y. That looks like xxy, not x times y. So mathematicians made a dot for that. Now, 4 times 4 times 4. Now, when it says write each product as a power, I bet you're like, say, what? I don't even get what they're saying. Well, basically what they're asking is a power is 2 to the power of 2. And I bet you're saying, what does that mean? Well, that basically means 2 times itself 2 times. So 2 times 2. That's what 2 to the power of 2 means. So if it was 2 to the power of 3, then it would be 2 times 2 times 2. You're getting the pattern? So they're just asking us to convert that into a power. So it's 4 times 4 times 4 times 4 times 4. So that's 4 times itself 5 times. So it's going to be 4 to the power of 5. Because 4 times 4 times 4 times 4 times 4. 1 4, 2 4, 3 4, 4 4, 5 4. So that's how you get that. And once you start getting the hang of it, you'll be like, this is pretty easy. I got this. So since we're anyways on a roll, and I bet you're like, thank goodness we don't have to calculate all of this. Next, let's write 12 times 12 times 12. Well, that would be 12. 1, 2, 3. 12 times itself 3 times. So it would be 12 to the power of 3. Simple, right? Nothing hard here. So now I want you to write these products. These are your example problems. 6 times 6 times 6 times 6 times 6 times 6. Did I write enough sixes? There we go. And our second problem is 15 times 15 times 15 times 15. And remember, you don't have to solve this. You just have to turn it into an exponent. That's what it basically means. So, remember what an exponent is? 2 times 2. Convert that into an exponent. It's 2 to the power of 2. So that's all you have to do. Pause the video here and solve the practice problems. All right, and hopefully you've solved it. This is 6 times 6 times 6 times 6 times 6 times 6. Got a tongue twister there. I bet you're like, that's a lot of sixes. Well, it's 6 to the power of 1, 2, 3, 4, 5, 6. There's 6 sixes, so 6 to the power of 6. And for a second one, there's 4 15s. So it's 15 to the power of 4. Super easy, right? No work to do here. Just put a bunch of numbers and you're done. Now we have to start finding the value of the power. And if you're like, I'm freaking out, I can't do it. Well, you don't even have to do much. So let's say that we have to find the value of 7 squared. Well, that's 7 times 7. I don't know if your teacher will let you use a calculator, but I myself have memorized all of these up to 15. So I'm telling you to do the same thing. 7 times 7 is 49. If you need a calculator, you might want to improve on that. And then our next example which I'm going to show you is 5 to the power of 3, which is 5 times 5 times 5. Now, we know that 5 times 5 is 25. What's 25 times 5? Now, this I have memorized. You don't have to memorize this. You can use your calculator, but I know that the answer is 125. So, for our next example, 64. Let's say that we take 64. And the question is asking us, determine whether each number is a perfect square. And you're like, say what? Well, basically what that's asking is, if a number is a perfect square, then basically it can be, so you know how we say 2 to the power of 2? It's also known as 2 squared. If we say 2 to the power of 3, it's also known as 2 cubed. And I bet you're like, hey, does 2 to the power of 4 mean 2 quadrupled? And no, it doesn't. There's only squared and cubed. That's it. Sorry. So what a perfect square is that the number can be squared. So which number can be squared to get 64? If you guessed it, it's 8, because 8 times 8 equals 64. So 8 squared would make 64. So since there is a number which square does make 64, then 64 is a perfect square. Now, next, let's take a number like 20. Now, what number squared equals 20? Let's think about it. Is it 1? No, 1 times 1 is 1. 2? 2 times 2 is 4. 3? 3 times 3 is 9. 4? 4 times 4 is 16. We're getting closer. 5? 5 times 5 is 25. So 4 times 4 is 16. 5 times 5 is 25. But it looks like there is nothing for 20. So 20 does not have a square. So 20 is not a perfect square. Wah, wah, wah. So all the questions don't have to be yes. There could be some numbers where they are not perfect squares. So keep that in mind as I give you 6 practice problems. 6 practice problems. Your life isn't going to end if I give you 6. First one is 6 cubed. Next one is 9 squared. Then 3 to the power of 4 and 18 squared. Then, actually, I'm just going to give you these 4. There's actually 8 of them, not 6. I'm going to give you these 4, and then I'll give you the other 4 in just a second. So I'm waiting. All right. And now we're going to solve it. So 6 cubed basically means 6 to the power of 3 means 6 times 6 times 6. And we know that 6 times 6 is 36. And then 36 times 6 is 216. You can use a calculator if you needed a calculator to calculate that. The next one is 9 squared, or 9 to the power of 2, which is 9 times 9. And 9 times 9 is 81. You can use a calculator for that too. Now this one's a hard one. 3 to the power of 4 is 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Why did I write 9? It's times 3, not times 9. And then 27 times 3 is 81. I memorized that. But you don't have to memorize that. You can use a calculator for that. And then our last one is 18 times 18. 18 squared, which is 18 times 18. And 18 times 18 is 324. I memorized that too, but you can use a calculator since that one's a kind of a complex one. Okay, so we finished our first 4 practice problems, and then the next 4 is determine whether the number is a perfect square. Remember what a perfect square is. 64 is a perfect square because 8 squared equals 64. So it's basically what number squared equals the number. But if there is no number squared, like 20, then 20 isn't a perfect square. So remember about perfect squares while you're doing these problems. First one's 25. The next one is 2. Then 99. And then 100. And I'll be waiting. All right, 25. What number squared equals 25? Well, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. So this square is 5. So this is a perfect square. Check. 2 is 2 a perfect square. 1 times 1 is 1, 2 times 2 is 4. Looks like there is no square to 2, so sorry 2, but you're not a perfect square. Let's try 99. We can skip all the way to 8 squared, which is 64, 9 squared, which is 81, and then 10 squared, which is 100. So 99 doesn't have a perfect square. And then as I said, 10 squared equals 100. 100, you are a perfect square. Congratulations. So hopefully you understood that, because now we'll be moving on. And we have one last example, one last practice problem, and phew, we can all be done. So, over here, for our last problem, squares are perfect squares. That's how they got the name perfect squares, because a square, both of the sides are always equal, right? So 3 times 3. So you don't actually, if you know one side of a square, you can calculate its area. And if you're asking how, well, since squares are equal on both sides, this side will also be 3. So we can do 3 times 3. And remember, 3 times 3 is 3 squared. How do you think it got the name squared? From a square. Get it? Yeah, it's not funny, I know. That's just a little info. So let's say that we had a square and one of the sides was 20. What's the area of the square? Let's think about it. Well, if the other side is 20, then it will be 20 times 20. Right, Rishi? And then 20 times 20 is 20 squared. And 20 squared is 400. And I use a calculator. I didn't use a calculator, but you can use a calculator if you want to. So now that you know how that, I'm going to give you a stop sign. No, not a stop sign, but just a sign. And one of the sides is 24. Find the area of it. Okay, for this one, if you're like, I'm stumped, this is a diamond. Well, guess what? If you flip the diamond so that it lies on its side, guess what it becomes? It's a square. It's just a tilted square. So we know that the other side is 24. Other side is 24. So we have 24 times 24 to calculate the area, which is 24 squared. And if you want, you can use a calculator. I'm not going to use a calculator. I'm just going to pull it from my brain. And 24 times 24 is 576. So, the area is 576. So, quick recap. Today we learned about how to transfer things into exponents. So 2 times 2 is 2 squared. How to solve exponents. 7 squared is 49. What's a perfect square? 64 is a perfect square. 20 is not. And how squares are related. If a square has 3 and 3, then it's 3 squared, which is 9. So, hopefully you learned something. And now we know 1.2. So now we can waltz over to our graph over here, checklist, I guess, and check off 1.2. We're on a roll, and next I'll be teaching you 1.3. So I hope you guys enjoyed the video. Don't forget to like, subscribe, and turn on the notifications bell to get notifications, and I'll see you guys in the next video.